Use limit laws to evaluate and justify each step. So the first thing I'm going to do is use the quotient limit law that says the limit of a quotient is a quotient of the limits. So that means I can take and compute the limit of the numerator and then take the quotient of that with the limit of the, as x approaches 2, of the denominator. Next thing, I'm going to take the numerator, and I see that it is a difference, and so I have the limit as x approaches 2 of 3x squared minus the limit as x approaches 2 of 4x, because the limit of a difference is the difference of the limits. And in the denominator, the same thing. So I have the limit as x approaches 2 Is that going to a funk? Is I am going to move these constants out in front. And the last one, and because I'm about out of room, I'm going to apply both of those. So the limit of a constant times a function is a constant times the limit of the function. And after I get that constant out in front, the limit of a function to a power is the limit of the function and then raised to the power. And so I can write this as 3 times the limit as x approaches 2 of x, and then I can square that. And then I will have minus, and this is a constant times a function, so I can multiply the constant after taking the limit. And then in the denominator, I have a constant and I also have a power, so constant multiplied after taking the limit as x approaches 2 of x, and then apply the power. And then here I still have the limit as x approaches 2 of 36. All right, so the reason we would want to do that is because now we know that the limit as x approaches a of x is just a. So in this case, I put a 2 here and then square it, which is 4, multiply it by 3 and get 12 minus. So I can put a 2 here and have 4 times 2, which is 8. And I can put a 2 here and then cube it, which is 8, times 5, which is 40, minus, and the limit as x approaches 2 of a constant is just going to be that constant. So I would then have 4 over 4, or 1.